Good evening, my warriors. It's time to revise with me, Shreyas, your physics master teacher at Vedantu, going live. Hello. Hi, Kiran, the gamer. Hello, Zayed, YouTube. Welcome aboard. Long time. How was your Diwali? Do let me know in the chat box. Did you have a lot of sweets? Did you become a little bit fat? Hello, Shruti Misal. Hello, everyone. Welcome back to the Pathfinder series. And like you all know, I have completed the term 1 syllabus back in October itself, and we have been continuously revising, also helping those students who have some backlogs with these crash course series, one-shot sessions to revise all your term 1 syllabus. I have also discussed the sample paper of CBSE in case you haven't checked it out, and all the detailed classes of all the term 1 chapters are there in the playlist of this channel. So go ahead, check it out, and welcome aboard Aishwarya, Pawan. Welcome. Good evening. Shruti had an amazing Diwali. Hello, Harish. And what about others? I am very good, and I am very thrilled to start my first class with you all. And it feels very different. It feels like it was probably a century back that I saw you guys, but I'm very happy to be back. And there is lots and lots of work to do because we just have a month or so for the upcoming term 1 examination. And those of you who do not know me, I am Shreyas. I am the HOD Physics JEE division, and I have been training students for almost like a decade now. And over the last couple of years, many of my students have got really good ranks. They have entered IITs. Many of them have even graduated from IITs and all the other top-notch institutes like ISCs and NITs, BITS, all the top institutes that you can think of. So having said that, I am here on YouTube to make sure that every kid out there, be it in our country, be it outside, benefits from this channel. And this is an English medium channel, so that way we can cater and reach out to all the students across the borders, and glad that you are here. And if you want to know more about me, you can definitely follow me on my Instagram handle. Hello Cholan, welcome. Hi Siva Ganesh, Ramya. Sir, I'm feeling cold due to excess sweets. How? I didn't get the relationship. Sweets and cold? I'm not sure. How does it work? Sankar, you need to explain me the logic. Arnav, hello, welcome. Hi Niranjana, kaise ho? Yes, Vicky. Now you're perfectly correct, Vicky. Now there'll be lots and lots of sessions. Are you ready? Okay, because there are going to be lots and lots of sessions because term 1 examination is coming. Plus your KVPY examination got postponed. So we have more time for practicing for KVPY. Plus we can also start few chapters maybe, of the term 2 syllabus, just because we have that time. So let's see what all we can do. Thank you Hemavati so much. Okay, Celeste, even if you're a dropper, you can watch these sessions because you have that time. Number 1, number 2, the 11th standard series and the 12th standard series together will help you for sure if you're taking a drop. So welcome aboard, and in case you haven't smashed the like button or hit the subscribe button, do that now because that's a small token of love from you towards me. And let me also announce, in case you do not know about this, there are lots and lots of students who cleared JEE Advanced and JEE Mains this year. Almost within 10,000 All India rank, there were more than 900 Vedantu students who cleared JEE Mains. And there were almost like 1,500 plus students who cleared JEE Advanced this year alone, which is 3 times more than the last year. Every 6, or I would say almost like about 6% of the students who are going to enter into IITs will be a Vedan, and that's what will make you probably a bit more comfortable when you find a lot of Vedans and all the students would have similar teachers or maybe similar mindset because they would have all come from the same kind of institute. So I'm pretty sure those of the students who have passed out will be really happy and proud about it when they find their dear Vedans out there. So you have to take this a level up, like all our dear students have increased their ranks from very big ranks to very small ranks. Like they were their ranks used to be in 10,000s, but eventually their ranks have come down to 3 digits and 4 digits. So that's what you all need to do. You have a lot of time and we are with you, and in case you want to boost up your preparation and you need some help, do not hesitate or do not feel shy. Please take help from all of us, because there is lots and lots of material. There are lots and lots of recorded live classes, and there are lots of test series, and all the kind of help that you would need for the upcoming JEE or the CBSE examination. The courses start as low as 2,340 per month. So for 11th or 12th, the link is there in the description box below. So let's begin. Hi Abhinav. Oops, my okay, my Siri just goes on weirdly. Okay, because of eating excessive ice creams and sweets during Diwali, now I'm not feeling well, and now you're suffering from cold. Oh, that's the relationship, Sankar. Please recover fast, and don't worry, you will have lots and lots of sweets when you clear your JEE examination. We'll have a big celebration, and that time you can eat lots of sweets, and then you can afford to fall sick, because then you don't have to worry about exam. But for now, at least for the next 1 year, please take care of your health and stay safe and stay healthy. All right, Sankar? Okay, so let's get going. Vanakkam everyone, and here are our lovely students. So make sure you bond well, help each other, and if you haven't subscribed yet, please hit the subscribe and smash the like button. Okay, so talking about force and fields. See, we have spoken about electric field, and we have spoken about the force which an electric field exerts on a charge. So any charge around it. Okay, so let's say I have a charge like so. Okay, let's say this is a charge. It creates electric field around it. So if this was a positive charge, then it will create outward electric field like this. And if it was a negative charge, it will create an inward electric field. So these are electric field lines. And we know whenever there is an electric field created by some charges, so let's say this is an electric field, and you place some other charge over it, then that charge experiences force, and that force which this charge experiences, so the force on Q due to the external field E is given by Q into E. I hope everybody remembers this. And let's see how many of you are quick to remember what's the unit of electric field. Come on, let me know in the chat box. Sankar, even if you're a NEET student, it's okay. It's perfectly fine. Physics is the same. Good evening, Abhinav. Welcome. Hello, Dheeraj. Hello, Poonam. Hello, Sunita. Good evening. What's the unit of electric field? Come on, my warriors. In case you have forgotten, probably you should start making those gears in your brains work. Let it start moving. What was the unit? Yeah, it was either volts per meter, or you can also use Newton per coulomb. Yeah, so either of them is the correct unit of electric field. Correct. Oh no, Shruti, that's magnetic field. Be careful. Yep, be careful. Yep. Yes. I do remember, Suhas. Yep. Welcome. And I hope you are going to prepare again. Yep. And in case you haven't cracked it, well, let me tell you, there is a dropper batch starting as well. Yes, Vicky, for KCT also that will be useful. Correct, it will be. All CTs, because the portions are very similar. Similarly, you have magnetic field. So a bar magnet or a coil which carries current. Let's say there is a current which is flowing in a coil. What does it create? It creates magnetic field. So this coil or this bar magnet will create magnetic field. And we all know that the symbol of magnetic field is B, and the unit of B is nothing but Tesla. Everybody knows the famous car Tesla. So Tesla is the unit of magnetic field. 1 Tesla is a heavy, large unit of magnetic field. So B is for magnetic field, E is for electric field. Now, just like an electric field can apply a force on a charge, Q into E is the force on a charge due to electric field. Same way, magnetic field can also apply a force on a charge. Now, a lot of you might be thinking, sir, I think I know this. Just like the force due to electric field is Q into E, then the force due to magnetic field is Q into B. Well, that's wrong. No, the magnetic field does not exert the same kind of formula force. Okay, so the formula is very, very different, and let's see what's that formula. So whenever you have magnetic field, some of you might have already started writing this down. No problems, Shruti. It's okay. Mistakes happen. Welcome, Danush. Glad you called me Thalaiva. I like that name too. Yep. So the force is QV cross B. Yep, it's a cross product of velocity and the magnetic field. So like you can see, velocity is here, magnetic field is here. So the force will be velocity cross magnetic field. And for example, let's say we have a charge, let's say it moves like this, and let's say the magnetic field is in this direction. Okay, it makes some angle, maybe theta. Then the force on this charge which is moving is given by F is equal to charge into velocity cross B. So using your right hand thumb rule, okay, start with the first vector which is velocity and go with the second vector which is magnetic field. So V cross B might come out to be like this, which is perpendicular to B as well as V both. So this is how the force will look like. Yep. And if you want to write it magnitude wise, you know what to do. You can skip the bar symbols. Just if you want the magnitude, it will be QVB sine theta. What is this theta? It's the angle between velocity and the magnetic field. Keep this in mind. Excellent. BIL is a different formula. Okay, so on a charge it is QVB. QVB, keep on saying this. Don't say QBV. Because when you say QBV, you might do a wrong cross product. B cross V is different from V cross B. Remember, cross product is not commutative. That means you cannot flip the variables and expect the same answer. Okay, so when you write A cross B, it is different from B cross A, at least the direction wise. So remember QVB, keep on saying this 10-15 times, it will definitely enter your head. So for a charged particle which is moving with speed V and a magnetic field B, the force is QV cross B. Okay, keep this in mind and use all the rules of your cross product which I have studied in the first chapter of your 11th standard, which is vectors. Keep that in mind. Okay, now because of this force, alright, because of this force, I'll definitely make a video out of that, Jaivan. Don't worry, there are a lot of videos coming out of it. Don't worry. Yep. Purushottam, apart from one-shot videos, you need to watch the full shot videos as well. Once you understand the idea of the chapter, you can watch detailed classes of wherever you find difficulty in. Okay, that's what you need to do, Purushottam. Okay. Oh, glad my minion is back. Nice to see my picture on the screen. Now, we just saw that the force is QV cross B and this force was perpendicular to velocity. Back in your 11th grade, you have seen that whenever you have a particle where the force is perpendicular to the velocity, what does it do? It performs uniform circular motion, and this force acts like the centripetal force, right? So it acts like the centripetal force. So if you take a charged particle and throw it inside the magnetic field, okay, and you make sure that the velocity is perpendicular to the magnetic field, okay, so then you will see that if the velocity is perpendicular, you can see the velocity is perpendicular to the magnetic field. Where is the magnetic field? It is inside the plane of the board. Velocity cross B will be like this. The force will be always directed towards the center and the particle will perform uniform circular motion. Keep this in mind. Okay, so when the velocity is perpendicular to the magnetic field, even the force is perpendicular to the velocity and it turns as it moves. So it only changes the direction, it never changes the speed of the particle. And there are two important formulas which you should remember. One is the radius formula, second is the formula for the time period of complete revolution. It's very easy, you can see my derivation classes as well. I've done this on YouTube. Okay, so when you equate F is equal to mv square by r, you will get the value of radius and you can also get the value of the time period. So very important formulas. Radius is mv by qb. Try to say this multiple times, you will definitely get a hang of it. mv by qb. Yep, keep this in mind. mv by qb is the radius of the circular orbit. Second important formula, because it is uniform circular motion, if you just do 2 pi r by velocity, which is the circumference by speed, that will give you the time. Because think about it, it's going with a constant speed. So the total distance traveled by the speed, this is nothing but the circumference and this is nothing but your speed. So that will obviously give you the time. Time is distance by speed. That's it. So you will get the answer as 2 pi m by qb. The interesting thing is there is no speed in the answer because vv gets cancelled out. Keep this in mind. Okay, great. mv is also the momentum. Yes, you can replace mv with the momentum, p by bq. That's also fine. You can write it because momentum is mass into velocity. Whereas remember one important thing in time period, it's 2 pi m by qb. There is no speed in the answer. It's independent of the speed. No matter how fast you throw it, it will always take the same time for the same charge and obviously the same mass. Correct. Okay, trust me, if I could watch the concert, I would definitely have watched it. But this is news. I mean, I wish I could also watch some concert. It's been a long time since I watched any of the things. But yeah, don't make me feel jealous. I hope you at least visited it, Strashti. Okay. Well, let's get going. Yep. And here is the next thing. And that is when, you know, your charged particle is not thrown at 90 degrees but at an angle. So keep this in mind. Again, whenever you have a charged particle and it is thrown not at 90 degrees but at an angle with the magnetic field, then always split the velocity into two components. One velocity along, one velocity perpendicular. So if this is theta, then this component will be v cos theta. This component will be v sin theta. Once you split it into two components, remember simple things. See, the component which is perpendicular, the one which is perpendicular to the magnetic field, it will do the same thing as before. We just saw, whenever you throw a charged particle perpendicular to the magnetic field, it performs uniform circular motion. So think as if this v cos theta is not there. Just think v sin theta is there. So because of that v sin theta, what will happen? It will perform circular motion. Correct? It will just perform circular motion with the speed v sin theta in that particular plane. So this speed will be v sin theta. But there is a catch. There is an additional component of velocity which is v cos theta. So think about it. There is v sin theta which is making it do circular motion. Additionally, there is v cos theta. You'll be like, sir, there is v cos theta in magnetic field. So this v cos theta will change. No, it won't change. Why won't it change? The reason is when I do v cos theta cross b, the answer for this will be 0. Remember, cross product of two parallel vectors is always 0. Yep, two parallel vectors is always 0. So that means, you know, this component will not be affected at all. So this component just stays as it is. So you have a circular motion and you have a motion along this direction. So you have v sin theta like this, which is doing circular motion. Simultaneously, you have v cos theta that way. So the motion looks like this, like a spring, like a coil, correct? And that is exactly called as a helical path. What is the path called? It's called as helical path. So the path taken by a charged particle which is thrown at an angle will be helix. But when the charged particle is thrown at perpendicular direction to the magnetic field, then it only performs circular motion. Because when it is thrown perpendicular, this component is not there. So it will only do circular. When that angle comes, this component will take it forward. So apart from doing circular motion, it also goes forward, which makes it look like a helix. Keep this in mind. Everybody clear about this? Everybody clear about this? Very, very important. Now there are certain important terms over here. What are the important terms and formulas? Remember, one is because there is a circle, you can see these circles will have a radius. What's the radius of the circle? That's one thing. Okay. And the second thing that you should know is the distance from one circle to the other circle. This distance that you're seeing. This distance is called as the pitch. So the pitch is nothing but the distance which is traveled after one revolution. So after one revolution, it does not come to the same point. It has gone slightly ahead. So that distance is called as the pitch. Keep this in mind. So pitch and the number two term, like I said, the radius. So the formula for these are very, very simple. So when you have radius, So whenever you have radius, it is nothing but usually mv by qb. But in this case, this v won't be the same velocity, because remember that velocity had two components. This component was responsible for circular motion. What is this component? If this is theta and if this is v, obviously that is v sine theta. Keep this in mind. So the radius will be mv sine theta by qb. That's the main change. Second thing, the time period will never change, because remember it is independent of the speed. So it is still going to be 2 pi m by qb. Same time period, it will not change. Last thing, the value of the pitch will be basically how much distance did you move in one time period along the axis of the helix. So think, along this direction, one component was v cos theta. If this was theta, this was v sine theta, this was v cos theta. So it is moving with a constant speed. So in one time period, how much distance did it move? So that's nothing but the pitch. So that's going to be v cos theta into time period. So that's v cos theta into 2 pi m divided by qb. Keep this in mind. Is that clear, my warriors? Is that clear, my warriors? Okay, I mean, just don't by heart the MCQs for now. Maybe it might work, but trust me, you have 1 month. Please understand them. So that's why watch these one shots, and wherever you find difficulty, please watch those lectures in detail. Don't take shortcuts, because it might probably give you few marks in the exam, but eventually in the main exam it might actually not fetch you those many marks. So that's why I'm saying watch the one shots plus the detailed classes. You still have time. Okay, so watch everything properly, then you will not panic during the exams, because once you have solved many problems on your own. See, when does panic come? Panic comes when you try to by heart things, but when you learn things, when you understand things, then you will not panic, because you know it. It's just like how you know to eat food. You never panic when you have to eat food. Or let's say you have to ride a cycle, you will not panic. You will panic for the first time when you ride the cycle, because you're not comfortable. When you're kids, you're scared where you might fall down, because you always take help of your parents or some elders out there who is holding the cycle. But once you learn the art of cycling, then you're not scared at all. So the same way, once you learn the art of solving problems, you will not be scared even during the exams, and you will be like, okay, fine, I can just do it. Okay, so practice a lot of problems and understand them. Is the first question coming up on your screen. Great, Solina. Good evening, Akash. Very true, Dhanush. Yep. Join in, Surya. You are just in time for the problems. I just revised the theory, but I'm pretty sure in case you attended my previous classes, you will be still able to solve these questions. A proton, a deuteron, and an alpha particle. All of them enter a magnetic field which is perpendicular to the field with the same velocity. What is the ratio of the radii of the circular paths? So one, we have proton, the second is a deuteron, the third is alpha particle. All of them enter with the same speed in the same magnetic field. They are all perpendicular. What happens when velocity is perpendicular? Recollect, uniform circular motion. I clearly told you. Velocity perpendicular to field, circular motion. Remember this. Okay, great. So what's the radius of those circular paths? I think I just made you by heart the radius. Okay, what was the radius? Yep, it was R is equal to mv by qb. What is same? Velocity is same, b is also same. What is different? Mass will be different, charge will be different. Okay, so let's think about m by q ratio for a proton, for a deuteron, okay, and for an alpha particle. So for a proton, atomic mass unit will be 1 AMU, okay, 1 AMU. Charge will be also 1 E. E is the electron charge. Think of it that way. 1 AMU, Q is 1 electron charge, or 1.6 into 10 to the power minus 19 coulomb. For a deuteron, it's nothing but 2 AMU, but charge wise it is only 1. Basically it's 1 proton and 1 neutron. So it's basically an isotope of hydrogen. Think of it that way. So isotope of hydrogen means there will be an extra neutron So the proton is same, charge is same, just the mass is twice. Alpha particle, 2 protons, 2 neutrons. So only the protons carry the charge. But wait a minute, 4 by 2 is same as 2 is to 1. I think now you got your answer. Now you got your answer. Come on, my warriors. Most of you would have got it. Some of you are saying D, option D. Yeah, is it option D? Think again. This is 1 by 1, which is 1. This is 2 by 1, which is 2. This is 2 by 1, which is again 2. 1 is to 2 is to 2. That's the ratio of the radius, which is option A. It's not D. I think you guys made a mistake out there. Just be careful. Yes, Jinan Mohammed is correct. Yep. So Surya, if you're getting low marks in board examinations, I would suggest you to see NCERT again and again with your JEE textbook like H.C. Verma. Practice all the back exercises, write it down 10 times at least, and solve problems from exemplar, and then also solve problems from the sample paper and the question bank and the case studies. Just do this much. Trust me, you will get very good marks. Okay? Yep. Correct. The option is A, it's not D. Very good. Now I think you guys understood it. Let's go ahead to the next question coming up on your screen. Now, 2 charged particles, M and N, they enter a space of uniform magnetic field with speeds perpendicular to the field. The paths are as shown in the figure. Which of the following could be the correct justification for the paths taken? Why do you think is, the path different? Is the charge different? Is the momentum different? Is the speed different? And whose speed or momentum or charge is more than the other? Only one of them is correct. So think about it. Yep, Dhanush, it's helium. Correct. 2 protons, 2 neutrons. That's what alpha is, but without the electrons. Yep, correct. So I hope I just hope that most of you get this answer. Think carefully. M is going in a smaller, probably radius. N is going on a bigger radius. You can see the deviations are different. So that should give the hint of what the correct answer should be. In case you have forgotten the formula for radius, you can use that. That will help you for sure. It's mv by qb. You can see M has a smaller radius. So M has a smaller radius, whereas N has a bigger radius. Okay. Now use this formula to compare the rest. Okay. Just see, how can you compare this? The charge of M is more than that of N. Obviously not correct. In fact, the M radius is small. If radius is small, mass should be less. Do you see that, my warriors? Check that out. Very, very clear. Okay. So similarly, the next thing that you should greater than that of, oh, sorry, it was not. My bad, I'm so sorry. It was related to the charge, not the mass. My bad. The charge of M is greater than that of N. The charge of M is greater than that. Where is the charge? Charge is in the denominator. If Q is more, the ratio will become small. The radius will also become small. So obviously, M, which has a smaller radius, it will have a more or bigger charge. That's why the radius has become smaller. So that makes sense for sure. I can mark A option. Momentum of M is greater than momentum of N. That doesn't make sense because, if momentum of M is more, because M into V is momentum, then M should have a bigger radius, but that's not the case. So definitely it is not greater. In fact, it is smaller. M into V is momentum. Momentum of M is smaller. Keep this in mind. Next, the charge of N is greater than that of M. I mean, if A option is correct, C option is obviously wrong, because A option said charge of M is greater than of N. C is saying charge of N is greater than that of M. That is obviously wrong because A is correct. Last option, the speed of M is greater than that of N. Think about it. Speed comes in the top, in the numerator. If speed is more, radius is also more. But M has a smaller radius. So M should have smaller speed. Look at that. M should have smaller speed, but this says it has greater speed. So obviously D option is also wrong. So only one option is correct, and that is option A. I hope that makes sense. Okay, I hope this is clear. No, it is not ACD. It is not ACD. It is only A. C is wrong, B is also wrong, and D is also wrong. Yep, it is wrong. I hope this is clear. Sir, whether always north polarity has anti-clockwise direction of current? Nothing like that, Digant. It depends on which side you are seeing it from. So Digant, Vijayan, I would always say please use right hand rule. So curl your fingers in the direction of the current. Wherever the thumb points, that's north pole. Remember that. Okay. Only option A is correct. A lot of you made a lot of mistakes. So that's why these questions are very tricky. Moving on to the next question coming up on your screen. This is also very interesting. Let's see whether you can solve this. There is a uniform magnetic field B naught J cap which exists in space. There is a particle of mass m charge which is projected towards x-axis with speed v from a point A00. A00 are the coordinates. A means x-axis 0, y-axis is 0, z-axis is also 0. The maximum value of velocity for which the particle does not hit the YZ plane. Okay, let's try to visualize this first. Only then I think we can solve this question. So this is my YZ plane. Suppose this is your YZ plane. This is your x-axis. This is your YZ. Okay, the YZ plane. Okay, this is your origin. Okay, over here, and you have your charge particle somewhere over here because that is A00. I hope that makes sense. This is A00. Now you are throwing it along the x-axis. Let's say you throw it like this. You do not want it to hit this plane. What do you need to do? Think. Magnetic field is, along the y-axis. Velocity is here. So force will be along the z-axis. So actually it will go along a circular path like this. Okay. So if you don't want it to hit the YZ plane, because try to see this, guys, magnetic field is over here, velocity is over here, V cross B will be along the Z direction, correct? It would be along the Z direction. I think I have shown the path this way. Maybe it will be the other side. Okay. So, yep. So it doesn't matter actually for solving this question, but still for accuracy's sake. So velocity cross B will make the force go inwards and it will go in a circular path like that. If you don't want it to touch the YZ plane, try to think at it or look at it from the top view. So when you look at it from the top view, things become very, very clear. It will look something like this. You have thrown the particle here. It's going in a circular path this way. If it shouldn't hit the YZ plane, that means this distance should be the radius. Does that make sense? This distance, what is this distance? This is the coordinate, which is nothing but A. This A should be the radius, then it will just miss it. And if the radius is smaller than A, then definitely it will not hit. So the critical radius will be the value of A. Is that making sense? So therefore, R will be equal to A, and R is nothing but mv by qb. So that is A. So therefore, V will be equal to QBA divided by M. Where is that answer? QBA divided by M. That is option A. Can you see that, my warriors? Yep, that is the answer. Excellent. Radius will be A. Correct. So, Jumalia, what has happened is that in this question, if you look at the axis this way, look at this. This is the y-axis. This is the x-axis. This is the z-axis. This is the YZ plane. The particle is thrown here. You don't want it to hit the YZ plane. And there is magnetic field here. And the velocity is here. So V cross B, if you do it, the force will come inside. It will come like this. The force will come inside. So the particle will turn like that. And if it does not hit it, that means the radius should be equal to this length, which is equal to A. That's all I have done, and I have used the formula for radius. I hope now you are able to visualize this. Is that clear, my bachcha log? Okay, moving on to the next question. Yes, Ranveer, if you have a backlog of this, definitely you should watch it. And wherever you find the concept to be slightly difficult or going over your head, Ranveer, then watch my detailed classes. I have conducted at least 5-6 classes on this chapter of magnetism. Watch those detailed classes, because don't take shortcut, else it will be half-baked knowledge. So always use one shot to build confidence and get an idea of the chapter, and then watch the detailed classes wherever you think you have loopholes or you need some detailed explanation in. All right, moving on to the next question coming up on your screen. Very good, Shreyas Sir. Indian. Yes, it is A. Yep, it is. Okay, great. So here is the next question. We have a proton, charge is given, mass is given, speed is given, everything, angle with the x-axis is given, uniform field is also given, and field is along the y-axis, the radius, time period and pitch. Come on my warriors, quickly think what should be the path taken by this. Forget the values, calculations are simple. What do you think will be the path taken by such a particle? Look at the data given, look at the wordings of the problem. Field is along the y-axis, the particle is thrown with a speed at an angle of 60 degrees to the x-axis. I think I had changed this. Okay, it was supposed to be 30. Yep, it is 30 degrees. Yep, it is thrown at an angle of 30 degrees with the x-axis. So think about it. What do you think will happen? What will be the path? Let me see if you have already answered. Come on my warriors. Yes, Anirudh, it will be an helix. So let's try and draw this. Magnetic field is along y-axis. Okay, so this is the magnetic field and this is along the y-axis. This is your x-axis and you're throwing the charged particle like this, making an angle of 30 degrees to the x-axis. Great. This is the velocity. So obviously this will have two components. One will be v cos 30, which is nothing but v root 3 by 2, and this will be nothing but v sin 30, which is nothing but v by 2. So these are the two components. Now remember which component is responsible for what. The one which is perpendicular to the magnetic field, which is this one. This causes that uniform circular motion. Okay, so because of that the particle will go in a circular path, and because of v sin 30 this will remain unaffected. Okay, because of that the circular motion goes forward. It creates that pitch in that helix. So we have already seen the formulas. Let's just use that. R will be m, that v perpendicular component, by qb. So mass is 1.67 into 10 to the power minus 27. Perpendicular velocity will be v root 3 by 2. What is the speed? It's 2 into 10 to the power 6. Okay, into root 3 by 2, because this 2 is there. V is done. What is charge? Charge is 1.6 into 10 to the power minus 19 into magnetic field. What is the magnetic field? 0.104, which I can write it as 1.04 into 10 to the power minus 1. Okay, this is what it is. I'll tell you what, you don't have to break your head over these calculations. Think about it. 1.6 into 1.04 will be slightly more than 1.6. Agreed? 1.6 into 1.04 will be slightly more than 1.6. Slightly more than 1.6 and 1.67 are very close to each other. That means this and this will cancel off. Agreed? This will be like same number divided by same number, so it will be almost 1. Great. This 2 and this 2 also went off, so I'm just left with root 3 and all powers of 10. So root 3 into, this is 10 to the power minus 27, 10 to the power 6, that will become 10 to the power minus 21, and this will go up and it will become this 10 to the power minus 1, 10 to the power minus 19 will become 10 to the power minus 20. When it goes up, it will become 10 to the power plus 20. Root 3 is 1.7. Okay, approximately, and this will become into 10 to the power minus 1, which is 0.17. Yep, almost. Yep, is that clear? Sanjay, cycloid is not a part of this. Here you have helix. Cycloid comes in rotational motion, not in magnetism. All right, great. Let's move ahead. Similarly, you can find the other things. Time period and the the pitch of the helix. So time period will be 2 pi m by qb. There is no velocity in the answer. So 2 into 3.14 into, what is the mass? It is 1.67 into 10 to the power minus 27 divided by charge, which is 1.6 into 10 to the power minus 19 into, what is it? Magnetic field. What is the magnetic field? it is 1.04 into 10 to the power minus 1. Again, you will see a lot of things will get cancelled. Again, you will see a lot of things will get cancelled. Like, look at it, my warriors. What and all are getting cancelled? 1.6 and 1.04. If you multiply it, it will be almost near to 1.67. So this and this and this will get cancelled. Yeah, numerator and denominator will be roughly same. Okay, so that 2 is there and 3.14 is there. So it will just become 2 into 3.14 is 6.28. So 6.28 into, you have 10 to the power minus 20 here. When it goes up, it will become 10 to the power plus 20. So minus 27 into 10 to the power plus 20. So this will become 6.28 into 10 to the power minus 7. So that many seconds. That's what you got. So you got the radius, you got the time period. And last thing, if you want the pitch, what do you need to do? So pitch is this velocity which is along the magnetic field into the time period. So it's velocity parallel to the field into the time period. That's the formula. Remember it. So that's it. V by 2. What is the speed? It is 2 into 10 to the power 6 by 2 into time period. What is it? 6.28 into 10 to the power minus 7. 2 goes. So it will become 6.28 into 10 to the power minus 1. So it will become 0.314 meters. That's the answer. Is that clear, my warriors? Yep, Sanjay, please ask. Okay, yes, Sanjay, I will take it up in the advanced class. Definitely I will take it up. It is a very good question. Yes, it is a JEE advanced type of question. Yep, I will definitely take it up. Definitely. Okay, chalo. Let's move on. Yep, these were the answers. I think we just got it. Okay, I hope you are all enjoying these questions. These calculations were very simple. It's just that you need to have patience. You need to know the formulas. Hello Zayed, welcome aboard. Yeah. Let's move on. A uniform electric and magnetic field are produced pointing in the same direction. If an electron is projected with its velocity pointing in the same direction, what do you think will happen? While we determine the path of a particle with the help of components, Surinder, it will be easier to explain 2D motion as two 1D motions. So in 11th standard, in case you have not been taught this, I'll tell you this. It's very important to know. Why do you study 2D motion, resolution of vectors? Because when you study 1D motion, things are very easy along components in X, Y, Z. So the whole idea of 2D or 3D is studying 2 or 3 independent 1D motions. So combination of these 1D motions gives you that 2-dimensional motion. So that's why. So when you have this helical path, it looks very complex. So split it into 2 parts. One is circular motion. The second one is the straight constant speed motion. So when you combine both of them, you get the helical motion. So that's why we describe the path in the terms of components or the easier way of representing it. I hope this is clear. Definitely, Jay, you should definitely watch it for revision because these problems are not similar to the ones which I conducted in my long-term Pathfinder classes. So that's something which I have taken care of. Definitely you should watch it. Okay, chalo, let's get going. So Jay, instead of the flash series, because last year we did not have term 1 and term 2, so that's why I'm conducting this crash course kind of thing. So we'll have crash course and plus we'll have problem solving sessions, plus we'll have advanced problem solving sessions. So these together will help you, get that good knowledge about that topic. So that's what I'm trying to do over here because we have term 1 and term 2 separate. Hello Rudresh, welcome aboard. So Anjali, you can let me know what kind of directions you get confused with. I'll definitely help you out. So think about this. What will be the correct answer for this particular question? You have uniform electric and magnetic fields which are pointing in the same direction. So electric field and magnetic field are pointing in the same direction. And you have an electron which is projected with its velocity pointing in the same direction. So you have an electron also thrown here. Will electric field apply any force? Will electric field apply any force? Will magnetic field apply any force? And if it does, what are the directions? Think about it. Think about it. Will velocity be constant? Okay, Dhanush has started thinking. First of all, magnetic field will not exert any force. Reason, V cross B will be 0. Keep this in mind. Why? Because cross product is 0. So Why is cross product 0? Because sine theta is 0. Why is sine theta 0? Because theta is 0 degree. Angle between velocity and the magnetic field is 0. Sine 0 is 0, so V cross B is also 0. So force because of the magnetic field is not there. But electric field will definitely exert force, QE. But the problem is this charge itself is negative. So the force will be this way. The force will be this way, opposite to the field, because it's a negative charge. If it was positive, it will be that way. Speed is that way, force is that way. What's going to happen? The speed is going to decrease, but it will move in a straight line. Yep, straight line. I hope that is clear. Yes. So the electron's speed will decrease, and obviously option A will be correct. That's the answer. I have already covered gravitation, Ranveer. Just before Diwali, I conducted 3 classes separately, exclusively for gravitation. It is a part of 11th standard syllabus. So I have covered it. So please watch it. It's there, okay? Do not miss those classes. All right. Great. Variation of G due to Earth's rotation. Yep, I have told the formula, but if you need the derivation of that, I have done the one in the derivation course, but that's a good idea. In fact, I can make a short video on why the value of G will reduce because of Earth's rotation. So that I can probably make a short concept video maybe sometime later. But yes, I have explained the terms and the concepts involved in the speed, G variation due to Earth's rotation in the second class or the first class. Just check it out. Okay. I hope that will help you. Great. Moving on to the next part. So let's talk about crossed fields and all of this. So whenever you have, electric field and magnetic field combined together, then a lot of weird things can happen, because electric field will apply a force, magnetic field will apply some force. But when electric field and magnetic field are in the same direction and the charged particle is left, and the only thing which will be there is the force due to electric field. Yes, the force due to electric field is the only thing which will be present, because the magnetic field will not exert any force, because the velocity will be parallel to the magnetic field. So this is the force by electric field. Okay, this is the force by electric field. Force by mass will give you the acceleration. So this acceleration is only because of electric field. Magnetic field will not do any kind of work. It will not affect it in any kind of way. Keep this in mind. Okay, so that's very simple. That's what we did. Great. All right, moving on. Hello, good evening, Divya Peter. Welcome aboard. All right, now there is a special case which you need to know. That is the crossed field, where velocity is perpendicular to electric field, which is perpendicular to magnetic field. There is this very special case. Electric field is also there, magnetic field is also there, velocity is also there, but they are all mutually perpendicular to each other. Now what happens is, look over here, electric field is downwards, so the force due to electric field will be also downwards on this charge. The charge is thrown here, the velocity is perpendicular to electric field, the force will be downwards. If the force due to magnetic field cancels the force due to electric field by chance, then the net force on the particle will be 0. I'll repeat, in a very peculiar scenario, when velocity, electric and magnetic field are perpendicular, and the force due to electric field cancels out by the force due to magnetic field, the net force will be 0. So the particle will just move in a straight line. It will neither deflect here or there. So that's a very peculiar case, and that happens when, look at this, magnetic field is inside, velocity is there. Magnetic field is inside, velocity is there. V cross B. 4 fingers first pointing towards V, then pointing towards magnetic field, which is B. My thumb goes up. So that's the direction of the force. So if QVB equals to QE, force due to magnetic field cancels the force due to electric field, the velocity will remain constant. It will not get deflected. And that happens when V is E by V. Yes, electric field by magnetic field. It's very simple. Very, very simple. Keep this in mind. Because you can see the derivation is also very easy. Like even if you try to do it, QVB is equal to QE. Like QQ gets cancelled. So B comes down. So V is E by B. As simple as that. So derivation is not a difficult part, but you should understand the directions. For electric field, the force is always along the field, but for magnetic field, the force is given by right hand rule, Q V cross B. And in that special case, when V, E, B are perpendicular and V is E by B, you will see the net force will be 0. It will just move in a straight line. There is no deflection at all. Okay, great. Good evening, Swati. Yes. Is this Hall effect? Yep. This concept is definitely used in Hall effect. You will see that in EMI, and I have done those kind of questions where you will see the electrons just migrate towards one side of the conductor, because of which there is a potential difference which is created. So the formula looks similar, but the theory behind is almost the same. Okay. Now let's do a question based on both the fields present together. Let's see if we can do this. There is a particle of certain charge and mass. It is thrown, okay, in this uniform electric field. Where is the electric field? Along I cap, that means x-axis. Where is the magnetic field? Along the z-axis, that means it's coming towards you. And it follows a trajectory from P to Q as shown. So it's thrown with speed v, it goes along some curved path and it goes here. And the velocities at point P and Q are, at point P it is v I cap, at point Q it is minus 2v j cap. It's already given. Which of the following statement is correct? Only one statement is correct. Let's see how many of you can get this. Let's see. Okay. All right. Thank you guys for keeping me enthusiastic, because that's number one. That's the name of the channel. We enthuse. So we are always enthusiastic. Number two, it's all your love and support, and the more you interact with me, trust me, I will stay more enthused, because I love interacting with you all out here, and I keep reading. Maybe I might not be able to respond to each and every one. Sometimes I miss some of the names, so don't feel bad, but I always see the chats. Good evening everyone. Join in, and let's see what the correct answer should be. From point P to point Q, who is doing work, who is not doing work? Is the magnetic field doing non-zero work at P? Rate of work done by magnetic field is only at point Q is 0. The rate of work done by electric field at point P is 0. The rate of work done by both fields at point Q is 0. Okay, interesting. Let's see. Is this lecture for JEE mains or advanced? It's for JEE mains, and then you start preparing by watching my JEE advanced classes. So obviously you need to clear your backlogs, and then you need to move on to JEE advanced, obviously. Okay, Eketek, let's solve this question. First of all, observe this. Whenever you talk about force due to magnetic field, F is equal to Q V cross B, by cross product's definition itself, this force is always perpendicular to velocity. Whenever you do V cross B, A cross B, the A cross B is perpendicular to A as well as B. So this force is perpendicular to the velocity. If it's perpendicular to the velocity, power, what is power? Power is F dot V. This is a dot product, and dot product of two perpendicular vectors is always 0. Keep this in mind. And what is power? It is rate of doing work. Rate of doing work. This is that rate of doing work is nothing but power. So power by the magnetic field's force is always 0 for moving charges, no matter how it is thrown, where it is thrown, in how much field it is thrown, no matter with what speed. So the magnetic field does non-zero work at P. This is obviously wrong. It always does 0 work. Rate of work done by magnetic field only at Q is 0. Only at Q it is 0. Wrong. At Q also it is 0. At P also it is 0. At this point is also 0. In fact, it is always 0. This word only is wrong. So B is also wrong. Is that clear? Yep, correct, Dhanush. Why dot product is 0? Because what is a dot product? Dot product is nothing but FV cos theta. What is this theta? This theta is 90 degrees. Why is theta 90 degrees? Because of this. Force is perpendicular to velocity. Remember, if velocity is here and magnetic field is here, if velocity is here, magnetic field is here, then this force, okay, is perpendicular to B as well as velocity both individually. Okay, moving to the C and D option. Rate of work done by the electric field at point P is 0. Now, if you look at electric field is here. Force due to electric field will always be in the direction of electric field. Agreed? Now, where is the velocity? It's parallel. So, the power due to electric field, which is F dot V, this will definitely be not 0. Reason, if you look at F dot V, which is nothing but FV cos theta, this theta is 0 degrees. Angle between force and velocity is 0. Cos 0 is not 0, it is 1. So in fact, force is doing some work and there is some power which is given by the electric field. So it is not 0. But here it is said is 0. This is wrong. Option C is wrong. It is not 0, it is non-zero. I hope that makes sense. Yeah. Moving on to the next one. Rate of work done by both the fields at Q is 0. Obviously, the work done by magnetic field is always 0. Be it P, be it Q. Electric field at this point Q will be applying, the velocity is down, but the force is still going to be here. Why? Because the field is there. Always remember, force due to electric field is always along electric field, either in that direction or opposite that direction. If it is positive, it is in that direction. If it's negative, it's opposite to the direction. Right? So the force will still be in the direction of electric field, but the velocity is here. And the moment they are perpendicular, the dot product will become 0. So both of them are 0. Option D is correct. Is that now clear, my warriors? So combination of electrostatics, magnetism and work power energy along with vectors. So 4 chapters in one question. 4 chapters in one question. Yes, correct, Swarlina. That's the correct answer. Thank you, Dhanush, for all the love. Bacha log. Let's move on. Did you enjoy this question? And if you're enjoying this question, don't forget to smash the like button down there. Okay, moving on to the next one. There is a particle of certain charge and mass. It starts moving from the origin under the action of electric field and magnetic field. Both electric and magnetic field are parallel. But the problem is the velocity is along j cap. That's very interesting. Velocity is along j cap. The speed of the particle will become 2v0 after how much time? Sir, in all cases, in vectors, do we determine a path with components, sir? Surinder, it's preferable to determine or to show the paths in components unless and until the equation of trajectory is asked. Remember, in projectile motion, y is a function of x tan theta minus half gx square by u square cos square theta. That formula was there. So that's the trajectory equation. So if they ask you trajectory equation, then it's just basically an equation of y and x. But otherwise, you see what the options are. Okay. So over there was no option. So it looked very difficult. How do I give the answer in? So in the exam, they will give you the options. So by the options, you will get a hang of what should be the final form of the answer. Okay, bacha? Surinder, let's do this. Now, first of all, where is the electric and magnetic field? It's along the x-axis, I believe. So electric field is here. The magnetic field is also here. But the velocity is perpendicular. So that is what v0 is. Okay. After some time, the speed becomes 2v0. Interesting. See, this is at t is equal to 0. After some time, okay, it goes in some weird path because there is electric field and magnetic field. What will happen? That electric field will create a velocity along the x-axis, correct? It will push it. The moment it gets some component, see, this x component will not be affected by magnetic field. So this magnetic field will not affect it. Why? Because the x component and magnetic field both are parallel. So force will be 0 because V cross B is 0. Correct? But this component will be affected by the magnetic field. V cross B. Velocity is up. B is here. V cross B. If you do it, force will be here. It will go in a circular path. So it will go in a circular path, but it will also accelerate along this direction. So it will be doing circular motion, and it will be also going in that x-axis. So that circular motion will keep on moving, propagating ahead, so it will look like a helix kind of. Now what you need to understand is, after some time it definitely gets a new velocity, which is 2v0. Interesting. But out of that 2v0, this component will still remain v0. Keep this in mind. You'll be like, sir, wait, how did this happen? See, after some time the velocity becomes 2v0. Remember, this velocity cannot be changed by electric field because it's already perpendicular, correct? So no matter how many times it moves, the electric field is perpendicular to this component. So it cannot change this. It can only change in this direction. Second thing, magnetic field can never ever change speed. Don't you know this? Magnetic field can never do work. I just told you. So if it can never do work, it can never change kinetic energy, it can never change the speed. So this component will always be unaffected because of E and because of B. It will just do circular motion, uniform circular motion. I hope this is clear. I hope this is clear. Everybody understanding this? So very, very important. This V0 is just used for uniform circular motion. So it will remain unaffected by both. So the only thing which comes in extra over here is this x component, which I call it Vx. And why has that Vx come? Because of, this is because of the acceleration by the electric force. By the electric force. That's it. I think we can find Vx and we can find out, what time it takes and all of that. It's not that difficult. I'll tell you how to do it. See, how do you find Vx? Think carefully. You can find Vx by using kinematic equation. How? Vx will be initial velocity plus acceleration into time. V is u plus at. What is initial velocity at time 0 in the x direction? It is 0. End it because there is no velocity there. What is acceleration? Acceleration is force by mass. What is force? Electric force, charge. What is the charge? Is it given? Yeah, I think it is Q. So QE, force by mass into time. Interesting. So I think to find out the time, I just need to know the value of Vx. Look at this. So if I need to know the time value, so it is nothing but m Vx divided by QE. What is the value of Vx? How do I find that out? Look at this, vectors. This is the final vector. These are the two components. We all know in the chapter of vectors, the final vector square is initial vector, x component square plus the y component square. So that's all you need to do. It's Pythagoras. So 2v0 square is v0 square plus vx square. So vx square will be 4v0 square minus v0 square, which is 3v0 square. Therefore, Vx will be root 3 times V0. So just replace this Vx with root 3 times V0. That is our final answer, which is option A again. Is it? Yep, it is. Lots of A's today. Lots of A's today. Looks like some of you already got it. Very good, Jay. Very good, Sanjay. Glad you're enjoying problem plus theory out here. But E is constant. E is constant, Raghav. E is a constant value. You can see that. E not I cap. Yeah, so that's the reason why I use kinematic equations. Yeah, so kinematic equations are valid when acceleration is constant. And why is acceleration constant? Acceleration is constant because force is constant. Why is force constant? Because electric field is constant. Why is electric field constant? Because there is no time term over here. I hope that makes sense. Is that okay, Raghav? Alright, no, C is not correct because there is a 2 in the denominator. There is no 2 over here. Okay, so C is not correct. Only A option is correct. No problem, happens. So these are the kind of silly mistakes you should avoid. And if you have more doubts, please use our doubt app. It's there in the Vedantu app itself. You can ask any doubts right from morning till night, all the 7 days. And there are doubt experts who will answer your doubts in all the subjects. So you don't have to Google and be misled by wrong answers or by incorrect solutions. So use that. And if you want the entire PDF of today's lecture, it's going to be available in our Telegram channel. The link for joining the Telegram channel is there in the description box below. Moving on to the next part. So, So Girija, it has already started, bacha. If you want to join it, you can still join it. And there are lots and lots of micro courses, including my courses, which are right now there in Vedantu Pro. So you can even join today and take the full benefit of recorded plus micro courses plus your batches which are there, which will cover the term 1, the term 2 syllabus as well. Okay, Girija, even for JEE, even for NEET. Now, whenever you have a charge which is moving, it gets affected by the magnetic field. So there is a force. When you have a current carrying wire, what is current? Current is nothing but motion of charges. So those charges will also experience force. So that's why a current carrying wire also experiences force due to magnetic field. Just take a wire, make some current flow through it, you will see it will bend if there is magnetic field around it. Okay, so that reason for bending or tilting or moving is because of the force on those moving charge carriers. So that force is given by IL cross B. Don't remember BIL. Lot of students and lot of institutes teach students BIL, bill. No, that is not correct. ILB. That's the way you should remember it. Reason? Because the order of these terms is important. L cross B will give you the correct direction of the force. Okay, B cross L will not give you the correct direction. ILB. Remember this. Number 2. Okay, number 2 that you should remember. Don't remember, left hand rule and all those things. Remember cross product. So you don't have to remember Fleming's left hand, swimming rule and all of that. L cross B, length, B. That's it. L cross B, use your normal vector cross product. That's it. You will get the direction of the force. You don't have to memorize and put things on your pointing finger, middle finger, thumb and ring finger, God knows. Don't do all those things. Okay. Now there are 2 important theorems. Rigid bodies, Ganesh, will be starting tomorrow, bacha. Sanjay, I'll make a special video for moving coil galvanometer. Okay, I'll make it. Yes, Ganesh, this is live streaming. Alright. Now, what are the 2 most important theorems? Whenever you have a curved wire which is carrying current, you can replace it with a straight wire for finding the force. Very, very important. So curved wire which carries current, whatever force it experiences is the same as a straight wire joining the 2 ends. Keep this in mind. Second important property, if you have a wire which is in the form of a loop, need not be circular, it could be any shape, but there is no start or no end, then the force will be 0. Remember this. Okay, these are 2 important properties which you should remember. So force on an incomplete loop or a curved wire is same as that of a straight wire. But on a closed loop, the force is 0 when it is placed in a uniform magnetic field. Keep this in mind. Moving on. Last formula before we start with the problems again. Deepak, there is long time for it. Okay, it might start in February or March. Okay, yeah. How to choose dot product and vector product in formula? So the thing is, you cannot choose, it's already chosen. You need to know whether dot product is used or vector product is used. One thing to remember, whether the final outcome should be a vector or should it be a scalar. Like for example, work, it's a scalar, so it should be dot product. Torque, it's a vector. Force, it's a vector, so there will be cross product in it. That's how you remember whether it's a dot or a cross product. I hope that helps. When you have parallel wires which carry current, then there is a force of interaction between them. What's the value of the force? That value of the force is mu naught by 2 pi I1 I2 by R into L. Very, very important formula. And how this comes is basically whenever you have a wire which carries some current, it creates magnetic field around it. This magnetic field will exert a force on the other wire which is carrying current I2. So this force is given by mu naught by 2 pi I1 I2 divided by R. What is R? R is the distance between them. And what is L? L is the length of that wire. L is the length of that wire. Some people also shift this L here and write it as force per unit length is only this much. That is also fine. One more thing. If the directions are same, then what will happen? And if the directions are opposite, then what will happen? Will they attract or will they repel? Okay, you should remember this also. If you have same charges, they repel, right? In magnetism, it is exactly opposite. So when you have currents in the same direction, they will attract. And when they are opposites, then they will repel. Okay, so it's exactly opposite of electricity or electrostatics. I hope this is clear. Jacob, I'm very good. Yeah. And yes, Deepak, they will. Hello, Payal, welcome aboard. Here's the first question. There are two long parallel straight wires A and B carrying currents 8 ampere and 5 ampere in the same direction, separated by 4 centimeters. Find the force on 10 centimeter part of that wire A. Very straightforward. Very straightforward. Come on. In physics, you have to give more time to sums rather than theory. You have to solve more problems. You have to study the theory. You should know the theory, and then you should test your theory by solving solved examples. And once you get little confidence, then you should only solve problems unless you get stuck, and then you need to revisit the theory partially and then again come back to problems. So 80% to 70% of the time is only solving problems. Okay, let's solve this question. So when you have two wires which carry current, there is a force between them. So what's that force? That's the question. Let's try and solve this. First of all, I think we'll start with our formula, which is mu naught by 2 pi I1 I2 divided by R into L. Now what is mu naught? Mu naught is nothing but 4 pi into 10 to the power minus 7. 2 pi is as it is. I1 I2, what are the currents? 8 and 5. So 8 into 5. What is R? R is the distance, which is 4 into 10 to the power minus 2. Length, how much is the length? 10 centimeters, which is 0.1 meters or 10 to the power minus 1 meters. So I think I can cancel a lot of things over here. Let's see. So 2 pi and 4 pi, this 2, this 4 and this 8, 2. 2 into 5, that's 10. Okay, I think we just have 1 2 over here. So 2 into 10 to the power minus 7 into 10 into 10 to the power minus 1. Both of them go. Again, this will also go. Only this 10 to the power minus 2 will come upstairs as 10 to the power plus 2. So it will become 2 into 10 to the power minus 5. So where is it? It's here, option B. Done, done. Very good, Swarlina. Very good, you are quick. Hello, Tamil A, welcome aboard. Deepak, yes, bacha, you will get, but you cannot wait for so long time. It should not be like you wait for some batch and you're not even prepared for it. So it's better to start preparing right now. You don't wait for certain batch. You start preparation. You make sure that you are, very well prepared, in the sense that you should get or aim for 100 percentile. Don't aim for qualifying for a batch. Always aim to get into IIT, because IIT is your end goal. Never prepare for a batch. Always prepare for your final destination, which is IIT. Keep this in mind. Okay, next question coming up on your screen. Some current I1 is being carried in this wire AB and it is perpendicular to another wire CD. Then if they are all free to move, okay, if this wire is free to move, then what will it do? Will it just rotate? Will it just translate? Or will it do both? Or will it not do either rotation nor translation? What do you think the answer will be? Some of you are saying B. Come on, my warriors, think about it. What do you think should be the correct answer for this question? Both the currents are perpendicular to each other. What should be the final outcome? Will they translate? Will they rotate? Will they move, or will they not move at all? Come on, my warriors, think about it. I feel this is simple. You can do this. Think about the magnetic field. Where will the magnetic field come? This CD wire, which is carrying some current over here, will create a magnetic field like this. Correct? So the magnetic field on the AB part will be inside, but it will be very strong here, and as you go far away, the field will become little bit weak. Is that making sense? The magnetic field by this wire will be circular loops. That field will pierce inside the plane of the board, and as you are close, the field will be strong, and when you go far away, the field will become weak. Next thing, because of this magnetic field, this current carrying wire will experience a force, and that will be IL cross B. Remember the formula, F is IL cross B. So how will the force look like? Length is there, magnetic field is inside. Length is here, magnetic field is inside. L cross B. L, first put my 4 fingers in the direction of length, cross B. Where is the thumb coming? It's coming up. So the force will be up. The force will be very strong here. It will be slightly weaker here, more weak here, and less weak here. Why is it becoming weaker and weaker? Because the field is becoming weaker as you go far away. That's it. The moment this happens, it should make sense that there is more force here, less force here. Obviously, it will translate and it will also rotate. So there will be rotation and translation both. So option C, correct, Varshini. Very good, Swarlina. Very good. It is not B, it is C. Be careful. It is not just translation. The reason is force is different. A lot of people forget that the force will become weak as you go far away because the distance increases. So hence both will be the answer. Correct, Balaji. Moving on to the next question coming up on your screen, and here it is. Let's see what it is. So you have a sine wave equation which is placed in a magnetic field perpendicular to its plane. The question is the force on one wavelength of the wire. Okay, the force on one wavelength of the wire. What is one wavelength? One wavelength is exactly this much. Now, if this is one wavelength, what is the force on a curved wire? I think I just gave you. The force on a curved wire is same as the force on a straight wire. Remember? And this straight wire is basically having the length of lambda. That's it. Your problem is solved. That force is I, L cross B. That cross product, which basically is sine 90. Why is it sine 90? Because it is perpendicular, right? So I, length is lambda, magnetic field is B. But remember, lambda from your equations of waves which you studied in 11th standard, you might have studied the relationship between lambda and K. What is the relationship? It is nothing but K is 2 pi by lambda. So lambda is 2 pi by K. Done, done. Just put it over here, you got the answer. So what is your final answer? Oops, I, and you have 2 pi by K into B. That's your final answer. Done, done. Yeah, this is a subjective kind of question. They can give you values. You just have to substitute and give or mark the final numerical answer over here. Very simple. So the concept here was the curved wire was converted into a straight wire. Second concept, waves. We know one wavelength is 2 pi by K or K is 2 pi by lambda. That's it. These were the two concepts used over here. Next question coming up on your screen. Let's see how many of you can give the answer. Come on, my warriors. You have a loop, semicircular kind, and it is placed in a uniform magnetic field of 1 Tesla as shown. The radius is also given. What is the force on the loop? Remember, the current is getting distributed like this. Be careful. There's a small catch here. Many of you might make a mistake. The current comes in, spreads and comes back. So what is the net force on this complete loop? Figure this out. Ram Kailash, this is a smart board. That's why I'm able to write over here. Okay, chalo. Let's see how to solve this question. First of all, remember, whenever you have a curved wire which carries some current, you can replace it with a straight wire. Replace it with a straight wire. But there is already one more straight wire which is carrying some current over here. So it's basically two straight wires from this point to this point. So essentially this problem is nothing but two straight wires of length. How much will be the length? Think about it. Radius is 1 meter. Length will be 2 times radius, which is the diameter, which is 2 meters. So there are two straight wires on which you have to find the force. So the force will be I, effective length into B. So I, what is the current? I think the current is 2 amperes. Length will be 2, but there are 2 of them. So that's why into 2. Into magnetic field. How much is the magnetic field? 1 Tesla. So that's it. 2 into 2 into 2, it's 8 newtons. That's option B. Correct. Oh, very good, Jinan. Very good, Chandu. Very good, Swarlina. Very good, Kumar. Oh, Kumar, it's not D. Yes, Brock, gravitation ho chuka hai. Pishle hafte, last week only, last week, just before Diwali I completed it. Was those 3 classes very, very important. Okay. It's done. You can watch it. Detail में हो चुका है. All right, 8 Newton. Next question coming up on your screen, and here it is. Come on, my warriors. This is also very interesting. There is a loop which carries current, and because it is placed in some magnetic field, it will try to expand. The question is, what's the tension in the wire? What's the tension in the wire because of the magnetic field? Think about it. When this loop carries current, let's say like this, if you take a small element like that, then if the length is over here, and if you do L cross B, right, then there will be a force which is always trying to, pull it, because of which there is some force within that wire. So because there is a force of tension in that wire, it's like you take a wire and try to pull it or try to squeeze it from all the sides. There is some tension in that wire. We can very easily find that tension, and I'll tell you how. Just consider half of that wire loop, only the semicircle. Just consider the semicircle. Okay. Now when you consider the semicircle, just think what are the forces acting on it. One force will be at this point, there will be a tension, at the second end also there will be a tension. Make sense? Tension here, tension there. Next thing, because it's a curved wire, it will experience force on all sides, but that forces which are acting on that wire, curved wire, can be replaced by joining a straight wire, and that straight wire will experience a force like this, let's say. So the force on that straight wire due to the magnetic field. So all have done is replace these blue forces with one single force by replacing the curved wire with one straight wire. That's it. These are the only forces acting, and now you can solve this question easily. So the force on the wire due to the magnetic field will be T plus T. T plus T. Upward force is downward force. What is the force on the wire? I into effective length into B. T plus T is 2T. What is the effective length? The effective length is 2 radius into B is equal to 2T. 2 gets cancelled. Okay, so you are just left with IRB. Where is IRB? It's here. That's it. Option A again. Yep. So no Chandu, you should not take L by 2 pi. It's not the circumference. Always replace a curved wire with a straight wire. Straight wire will be just 2R. Okay, so that's why the answer is A. It's not B. A lot of people make that mistake. It's not B, Jinan. It's not B, Payal. It's not, yeah, Darsh. Vachni, it's not B. Yes, Kavyan. It's not. Yeah, hello, Kavyan. In Darsh, it's not 0, bacha. Okay, there is some tension. See, think about it this way, bacha. Like if you have a wire, if you keep pulling it from all the sides, obviously there will be tension. Yes, the total force will be 0, but in the wire there will be tension. So the question is to find the tension. How did we do that? By splitting the wire into 2 parts, so that the tension which was internal force will now become external force. Because when you only take half of the wire, then these 2 tensions will become external force. I hope that makes sense. Both Kumar and Neat, you should use both of them. You don't have to consider the bottom arc, because the same tension will be there throughout the wire. It will not add up. The tension in the entire wire is the same. So either you find on the top wire or in the bottom wire. It's all symmetric. So you choose any one of them. You don't have to do both of it. Yeah. Is that clear, Jin and Mohammed? Yeah, you don't have to take both the wires. It's just symmetry that you have to use. Yeah, the answer is BIR. Last few concepts. Whenever you have a loop which carries current, okay, whenever you have a loop which carries current, then that loop behaves like a magnet, and that magnet has a dipole moment. So remember this. So whenever you have a loop which carries current, it behaves like a magnet. You can convert it into a bar magnet. So just like a bar magnet produces magnetic field around it, even this loop which carries current also produces magnetic field around it. There are 2 poles of a magnet. That's why dipole. Hence, a current carrying loop is also a magnetic dipole, because it's 2 magnetic poles, so magnetic dipole. And there is a magnetic dipole moment. What's the magnetic dipole moment? It is NIA. Keep this in mind. What is N? Number of turns. What is I? Current. What is A? is the area. Okay, NIA, very easy to remember. NIA, National Investigation Agency. Okay, just like you have CIA in America, in India you have NIA. Okay, so number of turns into current into area. Now, how is the direction given? Right hand rule. As simple as that. Curl your fingers in the direction of the current. See how the current is going. Wherever the thumb points, that's where the magnetic dipole moment is. Done, done. Now, when you place such a loop in somebody else's field, then it will experience a torque and it will also have some energy. That loop, it will experience a torque, it will try to come back. Okay, it will just like a magnet which is placed in Earth's magnetic field. If you rotate it, what does it do? It tries to come back. There is a torque on it. It has some energy associated with it. It's like a spring which you try to twist and it stores some energy, and you can experience that by leaving it. So when you leave that loop, you see it comes back. So it has some energy just like a spring would store energy. So it has potential energy. It also has a torque which it experiences. What's the formula? The formula is exactly similar to what you studied in electrostatics. Remember, torque on an electric dipole is P cross E. Here it will be M cross V. Instead of P, you have M. Instead of E, you have B. That's it. And over there, energy, potential energy was minus P dot E. Here it will be very similar. Instead of P, you have M. Instead of electric field, you again have magnetic field. So that's it, my warriors. Torque is M cross B and potential energy is minus M dot B. Keep this in mind. The torque which a loop experiences when placed in a field. These forces create a torque, that is M cross B, and potential energy is minus. That minus sign is very, very important. Okay, let's do a question on this. Let's see how many of you can do this question. Very interesting question. A circular current loop of magnetic moment M of some, it's placed in some arbitrary orientation of external field. What is the work done to rotate the loop by 30 degrees about an axis perpendicular to its plane? It's very interesting. Come on, my warriors, think about it. Very, very simple and very, very conceptual. If you have understood what is magnetic dipole moment and the torque, I am pretty sure you will get this. Think carefully. There is a loop, it is rotated by 30 degrees along its axis. Then what will be the work done in rotating it by 30 degrees? Let me make you visualize this. See, there is a loop which carries some current. This is the axis. This is the axis like this. So the magnetic moment will be here. There is external magnetic field somewhere in some random direction which I don't know. What have you done? You have rotated the loop by 30 degrees about the axis perpendicular to the loop's plane. This is exactly the axis which is perpendicular to the loop's plane. You rotate this loop by 30 degrees. If you rotate the loop by 30 degrees, will this angle theta change? Think carefully and answer. Will this angle theta change or no? No, it will not change because you just rotated the loop. M is still going to point up. Potential energy, which is minus M dot B, which is as simple as MB cos theta. Theta hasn't changed, B hasn't changed, M hasn't changed, U also won't change. If U hasn't changed, the answer will be 0 because there is no change in energy. Yep, Swarlina, it is D, correct. Many of you got it wrong. It is D. There is no change in the energy because M is still pointing upwards. There is no tilt in the axis. See, if that axis which was here, if you tilt it like that, then that theta would have changed. Then energy will change. But about that axis, obviously there is no change. I hope that made sense. So that's the answer D. So that's it for today, my warriors. And let me also tell you, if you're watching this video right now, there is a link for joining the crash course. And I'll tell you how. So you'll be getting the PDF number 1 of today's class by joining our Telegram channel link, which is there here. Now for class 12 students who are preparing for JEE, you have the Vedantu crash course, and you also have the dropper batch in case you're a student who is repeating 11th and 12th standard. That is for students who passed out this year but still want to repeat. There is a separate dropper batch. Just started today. Also, if you are preparing only for CBSE, there is a CBSE term 1 and term 1 and 2 crash course. All these links are there over here. You can see the prices are as low as 1,530 rupees using my coupon code SHHPRO. This is per month, and even though if it says 15 days, you get 15 days bonus additional subscription when you use this coupon code. So try it out for 1 month, because this price is not at all much. You get all the recordings, live classes, the material, assignments, test series, whatever you would require from a coaching. I'm so glad you were here, and that's it for today. I will see you again tomorrow. Have a great time. Stay safe and stay healthy. Bye bye. This was Captain Shreyas, and I was going live. Hasta la vista.